Hey guys, right now I'm going to go over how to solve a quadratic equation using the quadratic formula. Okay, so before we were using factoring to solve for quadratics, which is still, a perfect way to solve for the roots of a quadratic, but there might be an example where, let's say, we can't factor it. So, for example, let's say that we have the equation x squared plus 10x minus 34. Okay, we can think about it. Of course, we want to say, is there a greatest common factor? Are there two numbers that multiply to negative 34 and add to 10? The answer is no, they're not. So that means we cannot factor it into two nice numbers, this equation f of x. So instead, we're going to use the quadratic formula. This formula or equation right here is already written in standard form. So standard form, again, is when it's written in order, exponential, with x squared first, then the x, and then the constant term. So standard form is when there's a x squared plus bx plus c. Okay. In order to do the quadratic formula, use the quadratic formula, it does need to be in standard form. So if your equation was something like 34 equals x squared plus 10x, we would have to go ahead and move that over here by subtracting 34 on both sides. Okay? But because our equation's already in that form, let's go ahead and solve it. The quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay. First thing we're going to do with this equation is we are going to identify our a, our b, and our c. We can see our a is a 1, our b is a 10, and our c is a negative 34. Yes, negative 34, not positive 34, because that negative, that subtraction in front. Okay. Then we can go ahead and plug it into the formula. So we got x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. The first thing we're going to do here whenever we're solving for the quadratic is, for order of operations, we want to solve what's in the radical first. Okay, we know 10 squared is 100, so x equals negative 10 plus or minus 100. Negative 4 times negative 34 is positive 136. Okay, and then all over 2a. Again, we're simplifying what's in the radical first, so that equals negative 10 plus or minus the square root of 236 all over 2. We can go ahead and look at radical 236. If you would like, you can go ahead and just plug that into your calculator. If you would like to leave it in radical form, that's totally fine. I just ask that you simplify it. So if we're looking at radical 236 and we would like to simplify it, okay, you guys can look at the simplifying radicals video to review this, but we know that 59 times 4 is 236. Since we know the square root of 4, so we can rewrite this as, we know the square root of 4 is 2. So radical 236 simplifies to this. So we can rewrite our equation, x equals negative 10 plus or minus 2 radical 59 over 2. Our two answers then are x equals negative 10 plus 2 radical 59 over 2, and x equals negative 10 minus 2 root 59 divided by 2. Okay, these would be our two roots. Remember, it's a quadratic, so every quadratic has two roots. All right, and if you go ahead and plug that into the calculator, you will get 2 root 59 is equal to 15.3622914957, etc. Okay, I ask that if you guys are converting it to a decimal that you don't round until the very end, or don't round to the 10th until the very end. So at least keep it to 4 decimals. So this would be negative 10 plus 15.3623 divided by 2. And so our answer in decimal form would be 2.681. And the other one would be negative 10 minus 15.3623 divided by 2, which would be negative 12.68, which would be negative 12.681. Okay, so here you have your answers in decimal form. If you would like to plot it, so that means our roots here would be at negative 12.681 and at 2.681. In general, I will also accept answers in their most simplified form. So that means not stopping there. Okay, with radical 236, it means you do have to do the green part of simplifying that radical. Okay, so these answers are the same. There are two roots that you can solve for using the quadratic formula.